Ground control to Major Tom. Commencing countdown, engine Tom.
Take your protein. Hey, I was just checking out this microphone. It's really cool how a microphone can take the sound of my voice and convert it into this electrical signal.
Pushing and pulling back and forth.
That alternating current is much different than the electricity produced by a 9-volt battery, which moves in one direction. But let's say you wanted to prevent an alternating signal from moving backwards. That could be accomplished with a diode. You've probably heard of LEDs before, light-emitting diodes. But you might wonder, what exactly is a diode anyway? Well, a diode is an electronic component that lets electricity flow in one direction. It's a lot like a valve that prevents water from flowing the wrong way, but lets it pass in the forward direction. Some are designed for use with low electrical current. These are often called signal diodes. Others, usually much larger, are designed for use with higher current. These are usually referred to as rectifier diodes. A diode's ability to turn AC, or alternating current, into DC, direct current, is referred to as rectification. Now, a diode isn't perfect. It can only withstand electricity flowing in reverse up to a certain amount of voltage. This is called the breakdown voltage. Once this amount is exceeded, the diode's valve is essentially broken and current will flow in reverse. There are certain types called Zener diodes designed to have a specifically low breakdown voltage that can be exceeded safely without damaging the part. Many signal diodes are encased in glass, which makes it pretty easy to take a peek inside. This one here is classified as a point contact germanium diode, so named because it has a metal point held in contact with a germanium semiconductor crystal. Not much different from the first diodes ever made. In 1874, German physicist Ferdinand Braun was studying the electrical properties of crystals when he discovered what could probably be considered the very first diode. While probing the surface of a piece of iron sulfide with a thin metal wire, Braun found that electricity would move in only one direction through the connection he'd made. He went on to demonstrate the effect to the public, but few at the time understood the potential there. Indian physicist Jagadish Chandra Bose was using a similar setup with galena crystals. He used it to detect electromagnetic waves. In 1901, he patented it as a method for detecting radio signals. Braun's discovery had found a practical use. As their popularity grew, these crystal detectors, basically do-it-yourself diodes, became further developed by others. An electrical engineer from Portland, Maine, named Greenleaf W. Pickard, began experimenting with thousands of different minerals for use as rectifying diodes. He finally settled on silicon as the best choice and patented his silicon detector in 1906. Pickard would go on to start his own company, selling more permanent versions of the crystal detectors. At the basic level, these crystal detectors are really similar to point contact diodes. Point contacts are still in use today for high-speed applications, but most of the diodes you'll run into will use a different technology called a p-n junction. In 1939, Russell Schumacher Ohl discovered that by adding small amounts of specific impurities to a semiconductor crystal, one could control how well they conduct electricity. This process, known as doping, can be used to give a semiconductor either a positive p-type or negative n-type charge, depending on which impurities are added to them. When these two types are brought together, a p-n junction is formed, which will conduct electricity only in one direction. And there we have our p-n junction diode. Thanks to technologies like doping, diodes today are reliable and they're inexpensive. And that's great. But there's something uniquely cool about probing the surface of a crystal in order to create your own diode. In the past, I did have some luck creating my own, using silicon carbide, a needle, and parts from a helping hand device. You can still find vintage crystal detector stands and crystal samples available online. Using them effectively requires patience, curiosity, and a bit of luck, but the results can be uniquely satisfying. Diodes come in quite handy for power protection in test circuits. Some chips can be easily damaged if their positive and negative power connections are reversed. To guard against accidentally powering them incorrectly, use a 1N4001 rectifier diode in between your voltage source and the chip's positive terminal. This ensures electrons will only move in the correct direction through the circuit. For more good info, check out the following sites. And for the best in DIY technology, check out makezine.com.